Hi, in this section I will be revising the concepts of C and C++ programming that are used in this course. As the course is data structures using C and C++, basically the course is in C language. Plus, I have also shown how to write down the code in C++ also. It is added advantage if you know C++. Even if you don't know C++, it is sufficient to know C language. So you should be already knowing basics of C programming. You should already have some experience of C programming. And the concepts of C programming that are frequently used in this course, I am going to revise them so you are well acquainted or well familiar with those concepts and you can easily understand the rest of the topics. So in this section, I'll be going to discuss about basics about arrays. Though we have a big topic called arrays, a lot of things we are going to learn about that. But here basics about array I will discuss. Then structures in C language, then pointers, what are pointers we will study, references, parameter passing in C as well as C++, then classes, constructors and templates. These topics are related to C++, these topics are in C language, so these topics are more frequently used, and how to use them and what is the approach I am following, you can understand that approach from these topics. And one more thing, if you are already well familiar with C++ programming and you are a good programmer, I suggest you to go through this section so that you understand the style of programming that I have adopted in this course. And you get very familiar and it will be very easy for you to understand the rest of the topics. So let us start with arrays. So right now I will discuss a little bit about arrays. Then in coming videos we will learn about all these things one by one. So let us start with arrays. Arrays is defined as collection of similar data elements. If you have some set of integers or set of floats, you can group them under one name as an array. See, the method of declaring an array is, if you want an integer type array, let us say integer a of 5, then you get 5 integers, array name is a, and all those integers you can access them with name a. So this is an array and we get 5 integer spaces. And the indices will be 0, 1, 2, 3, 4. So 5 locations means the indices starts from 0 and at 4, total 5 spaces. Now I can store 5 integers. Every location is an integer. Every location integer. And if suppose integer, if we assume integer is taking 2 bytes, then these are total 10 bytes, 2 bytes each. Now each location can be accessed with the help of, like a of 0 assigned 27, so I can store 27 at this place. 27 is stored. Now a of 1, if I want to store something, then I can store a value 10 like this here. So you can have the group of elements together at one place. Now I will show you how to declare and initialize an array. I will main function. Now in this, suppose I want to declare an array a of size 5, an array of size 5 will be created. Now when the program is running, it runs inside the main memory. This is main memory, and the main memory is divided into 3 sections, that is code section and stack and heap. It will be inside code section, and when any variable is declared, like an array is declared, so that array will be created here inside the stack. This is where the array will be created, and that array will be directly accessible to the main function. And directly I can store the values, like already I have shown you. I can store some values 10, 5, 8, 3, 9. I can store them. This is how I can declare an array, and where the array will be created in the memory I have shown you. Now next thing, I will show you how to declare and initialize an array. This is the declaration of an array. Along with this, I can also initialize it, like 2, 4, 6, 8, 10. So array will be created and it will be already filled with the values. Like suppose an array B is created inside the stack, then it will be filled with the values 2, 4, 6, 8, 10. So this is declaration of an array, this portion, and this is initialization of an array. Together I can do, this is just declaration and this is declaration as well as initialization. Now next thing is how to access an array. For accessing an array, we can access all the elements one by one. Suppose I want to print all of them, then I can use a for loop. So for that I will take one variable I, and using for loop for integer I assigned 0, I is less than 5 elements are there, I plus plus, then using printf I can print it. So printf %d, I can say b of I. So here you must be familiar with the for loop. So I assign 0, I is less than equal to 5, I plus plus. So this will initially I will be 0. Then it checks that I is less than 5. Then it will print this b of 0. So it will be b of 0. B of 0, the element z2 will be printed. The next time I plus plus, I becomes 1. 1 is less than 5. So it will print b of 1. And so on up to b of 4. It will print all the elements. So for loop is used for scanning through the list of elements in an array. So more frequently we use for loop for accessing all the elements of an array. So that's it. This is sufficient because we have a very big topic called arrays. We are going to learn lots and lot of things about arrays. Just as an introduction, as a revision, I have done it. So that's it about an array. So the points that I have discussed, let me put them together. I have explained you what does it mean by an array and how to declare and initialize it, and when it is declared inside a function, then where it will appear inside the main memory. This is sufficient for now because we have a lot of things to learn about array. There is a big section called arrays. So there you will learn everything about arrays. So as a revision, I have discussed this much. That is sufficient. We have to learn about other topics. Let us continue in other videos.
Installed on your machine and you are learning this course. And if you have not done it, so you can go to the next section and install the IDEs. And one more thing, even you can practice online on an online compiler. I will show you where to practice. Open any browser, Chrome or Safari or Mozilla Firefox, any browser. Inside the browser, just search for online GDB. Yeah, this is online GDB, and you can select the compiler, either C compiler or C++ compiler, Java, whichever compiler you want, you can select here. So you can practice for almost all the languages. So here I will select C++ compiler because our course is in C and C++. So you can see that ready-made function is given here, right? Main function is given with IO stream, and using namespace is also included here, already written, pre-written. So you can select C++ and you can write on C as well as C++ programs. Both the programs you can write. So I suggest you can practice here online. You can start practicing here, right? In the next section, I am showing how to install IDEs. And if you like any IDE, you can start working there, or even you can practice here. So let us go back to the IDE. Now the next very important thing I should tell you. See, some student knows C++, they don't know C language. See, I should tell you that if you know C++, you already know C language. See, I have adopted both C and C++ style of programming in my course. So the C style program you can write on in C++. It's a C++ program also. Don't worry about it. You can easily write it, and I am also explaining the basic syntax that are required for practicing in this course. So let us start and see the demonstration for array and structure. See, I have already taken a C++ project. In my Xcode IDE, I have taken C++ project. You can see that hash include IO stream using namespace std, main method is there. Now, same thing, if you have a C language project also, you can do the same thing what all I am going to show you now. So let us create an array. See this array A of size 5. This is the array declaration. It will create an array of size 5 with 5 integers, and each integer can be accessed using its index. Like A of 0, I can store some value, that is 12, and A of 1, I can store the value, let us say 15, and A of 2, I can store some value, let us take it as 25. So this is how we can store the elements at each index in an array. So total indices that I will be getting are 0 to 4. See, these are 5 integers. So how much memory this array will take? It depends on the size of integer. See, latest compilers take 4 bytes for integer. See, in my whiteboard sessions, I am assuming integer is taking 2 bytes, right? For making my explanation easy. But in real, integer takes 4 bytes. So let us see the size of this one. So I can say cout size of A. Let us run the program. I should get the size as 4 into 5, 20. Yes, size is 20. Size of array is 20. Yes, it is printing 20. Now let us print some element. Cout A of 1. So what is the value? A of 1 is 15. Let us run it. Yes, I got the value 15. But there should be some space between them. So let us use endl here, that is for new line. So after printing 20, cursor will move to the next line and 15 will be printed in the next line. Yes, 20 and then 15, right? and I will give endl here also, so that this last message, this is coming from Xcode ID, will appear in the next line. Yes, 20 and 15, and then program ended with exit code 0. That's it. Now, can I use printf here? I want to print a of 2. Yes, I can use printf also. Printf %d and also /n, right? A of 2. Run the program. Yes, it is working. It is printing 25. It may not work in your ID. In my ID, it's not giving any error. If it is giving any error, then you can include stdio.h. See, inside a C++ program, I am writing C language code, right? So cout is for C++ and printf is for C language, right? So you can include stdio.h and write C++, mix the code also, right? See, all these things are same in C and C++. Only the difference is coming in cout and printf, right? So it's not a big difference. So far. Now let us learn next thing. Can I initialize an array? Yes, you can initialize an array by giving some elements directly. Like I will give the values like 2, 4, 6, 8 and 10. These are the values. If I run, here I should get 4 and here I should get 6. Let us see. Yeah, size is 20, this is 4 and this is 6. Then one more thing. When I am initializing an array, I can skip the size. So what will be the size of this array? As many elements you are mentioning here, that will be the size of an array. So the size of an array will be still 5. Yes, 5 4 is 20. I will include few more elements here, 12 and 14. So now the size of the array is 7. So the size should be 7 4 is 28. Yes, size is 7 4 is 28. So I am getting the size as 28. So it means the array size is 7 because I have initialized with 7 elements. Now let us look at next thing. I will give the size. I'll give the size as 10. But there are only 7 elements. 0 to 6 I have the elements. At the 7th index and 8th index there is no element. What will be present there? So I will try to print the element from index 8 and at index 9. Let us see what it will print. See, the size is 10, so the indices will be 0 to 9, right? So I am taking last 2 indices. Let us see what is there at that location. The values are zeros. So it means if you have initialized a few values from an array, then the rest of the locations will be having values zeros. So I will try to remove this. So I have only 2 elements, right? I will try to print the next element, that is at index 2, right? And at index 3. So I have the elements at index 0 and 1. So what is there at 2 and 3? Let us check. It is 0. So it means if you have an array of some size and initialize few elements, then rest of the elements will by default become 0. So can I write just 0 here? What will happen if I write just 0? So the only one element is initialized, that is 0, and rest of all the elements will be 0. So the entire array of size 10 will be initialized with 0. So this is how you can initialize the entire array with 0 if you want all the elements to be 0. Now the next thing. I have shown you how we can display an array. For displaying an array, we can use a for loop. For integer I assign 0, I is less than, we know the size is 10, I plus plus, right? So we can print all the elements, that is a of I, and also I will give endl. So I will remove this rest of the printing. So for loop is used for accessing all the elements in an array. So here I am just printing all the elements. So all the elements are zeros. Yes, 10 elements are zeros. I will try to initialize the elements with some values 2, 4, 6, 8, 10 and 12, and the rest of the elements will be definitely zeros. So you can see all the elements 2, 4, 6, 8, 10, 12, and rest of the elements are zeros. See, I have mentioned the size as 10, so inside the for loop I can directly use 10, right? So we have to give some constant value. It's a better idea to give a constant value as the size of an array. Now next. Is there any other method for accessing all these elements in an array? Yes, in C++ there is a for each loop. So let us use that. How to write it? I can take some element x from A. So I am assuming that you already know C and C++. I am just revising. Don't ask questions on this one. See what is for each loop and all. So I am assuming you should know about it, right? So if you are new to it, I suggest you to study about it. I am just using a for each loop here. Int x. So what will happen to x? X will take the value 2, then 4, then 6, then 8 and all. So it will be taking all the elements from an array one by one, all the elements. So how many elements are there? 10 elements. So it will take all 10 elements. right? So it will take the number of elements depending on the size of an array. Let us run it. Yes. So 2, 4, 6, 8, 10, 12, and the rest of the elements are zeros. So yes, you can also use the for each loop. Now more on arrays. Let us take the size of an array as input. Is it possible? Can I create an array of our desired size? Let us check. I want to take input from the user. I will write C++ syntax here. Enter size, right? So how much size of an array you want? C in n. Then is it possible to mention n here? See, what I want is, I will take the input from the user, that is size of an array, then I am reading the size, then I am creating an array of size n. Is it allowed? See, I am getting an error here. Actually, this a of n is allowed and it is called as variable sized array. This variable size array is allowed in C language also, latest compiler of that is C language. In old compilers it was not available. Then in C++ also it is available, right? It is used at very rare places in my course. Alright. Now what is the error I am getting? It is saying that you cannot initialize this variable size array like this. So you cannot initialize. This is the drawback of this one. You can create it, but you cannot initialize it. Then what will be the values in this one? It will have all garbage values. We cannot initialize it. Then how I can assign the values? You can take them from keyboard, or you have to use the indices and write on the values like this, or write them or fill them using loop by taking input from the keyboard. So let us run and see. Enter the size. Array size is 7. I'll give the size as 7. So let us see. First element is 2 that I have initialized it. Rest of the elements are garbage. So total how many elements are there? 1, 2, 3, 4, 5, 6, 7. Right? So total 7 elements. I have given the size as 7, so the size of an array is 7. Right? And here for each loop is working on this variable size array. In some compilers it may not work. Right? So just make sure your compiler is supporting or not. And in some compiler, if you try to initialize, it will not give you error, but it will not work properly. Here in my compiler, it is giving an error. It is saying that you cannot initialize it. But some compilers don't give any error, but they don't work properly. They will not initialize it. Alright. So remember that variable size arrays cannot be initialized. Alright. So at most of the places in my course, I need initialized arrays. So that is the reason I have not preferred using variable size arrays. Now one more thing, some students may get confused here that one of the values initialized with 0. I am saying that all are garbage, then one of the values is 0. How it is possible? See, 0 is also garbage. We did not keep this value. I have kept only one value, 2. So all other values, whatever it may be, it is garbage. Garbage means it doesn't belong to you. You have not assigned it, right? So all these values are garbage. These are values. Garbage are also values, but that is not your value. That's it. Alright. So that's it. This is the demonstration of an array. So I suggest you just practice this and try out all these things on your machine once, so that it becomes a revision and it will be helpful in further topics.
In this video, we will learn about structure. Structure can be defined as a collection of data members that are related data members under one name. And those data members may be of similar type, may be of dissimilar type. So usually it is defined as collection of dissimilar data items under one name. That is grouping the data items. Structure is used for defining user-defined data types. Apart from the primitive data types, what we have in any programming language like C language, we have primitive data types like integer, float, double, so on. Using these primitives, we can define our own data type depending on our requirement. So this is structure I am using more frequently in my course. So in this video, we will learn how to define a structure and what does it mean by the size of a structure, like how much memory it consumes, then declaring a structure, then accessing the members of a structure. Let us learn about these things one by one. Let us take an example of a rectangle. A rectangular figure will have properties like length and breadth. So it will have length and breadth. These two things together defines a rectangle. So if in your programs you need something like a rectangle, then you can define a structure for it, because rectangle is not defined by just one value, it is defined by a set of values. So that is length and breadth. So we can group them together under one name and define it as a structure. For example, rectangle. So here I define struct rectangle. Now inside this, I will take integer type length and integer type breadth. Now this is having two members that are length and breadth. I am taking them as integer type. If you want, you can take them as float or double, any type depending on your requirement. I am assuming that these are simple values which are integral type, no decimals are there. So structure rectangle is defined by its length and breadth. These two members together are defining a rectangle. So this is a definition of a structure. I have taken an example of rectangle. I'll be showing you more examples upon structures later on. So let us learn further about this one. Now, how much memory this rectangle will be consuming? See, it is having two members. This length integer type, if I assume integer takes 2 bytes, or it may take 4 bytes, but I am assuming it has 2 bytes. Now breadth also takes 2 bytes. Total, it is 4 bytes of memory. So this is structure is taking 4 bytes of memory. Right now it's not consuming any memory because it is just a definition. So if I create a variable of this type, then it will be occupying that much memory. Now we have seen how to define, we have learned how to know its size. The size of a structure is the total amount of memory consumed by all its members. Now next, let us learn how to declare a variable of that type structure. So inside main function, I will write on a main function. Now inside a main function, if I declare a variable, so the method of declaration is write struct as a keyword, then give the name rectangle, then I'll give the name as R, rectangle R. This is a declaration. Now this R will occupy memory space, right? This will be created in the memory. So how it looks like R is of type rectangle, so it's having two members, that is length and breadth. So R will occupy total 4 bytes, and first 2 bytes are for length and next 2 bytes are for breadth. So yes, that is occupying memory. This is the method of declaration. Now, if suppose I want to initialize it, then I can declare and simultaneously I can initialize it. So let us say struct, I will rewrite the same thing. I will say rectangle, right? I'll use the same name, R, with values, I can say 10, 5. So length is 10 and breadth is 5. So 10 and 5 will be filled in this one. So this is how we can declare as well as initialize. This is just a declaration, right? And this is declaration plus initialization together. This is declaration plus initialization. Then inside the main memory, if you want to see where this R is created, so it is created inside the stack for the main function, is inside the stack frame of main function. So R will be having length and breadth. This is length and breadth, and this is 10 and 5. So I'm showing them side by side. So we have learned definition, declaration, and initialization. Now, how to access the members of this structure? Suppose I want to access this length. I want to modify it to 15. So for accessing the members of a structure, we should use structure variable name and a dot length. So this is length, assign 15. So this value will be changed to 15, right? So it is changed to 15 in the memory. So this is how we can access. So what is the operator used for accessing a member? Dot operator is used for accessing a member. Then r dot breadth, I can modify it. R dot breadth, assign 10. So this is modified to 10. So if you want to read or write the members of a structure, dot operator is used. Here I will calculate the area of a rectangle and show you. So directly I will print the result, printf area of a rectangle is area of rectangle is percentile d. So here I will write the formula. So what is the formula for area? Length into breadth. So how to access that length and breadth? I have to use dot operator. So say r dot length multiplied by r dot breadth. So this is how I can access the members. So length and breadth will be multiplied, that is 15 into 10, and I'll get the result as 150. So that's it about the structure. This is sufficient, and more about the structure I will discuss when I talk about pointers and functions. So this was just the introduction to structure. So let us continue with the other topics in the next videos. So that's it. We have learned about how to define, how to declare, and how to access the members, and where it is created in the memory when you are directly creating or declaring it inside the main function, right? Declaration or initialization, where it is done. So it's inside the stack frame of that particular function. Now I will give you few more examples of structure. So I will write down few more structures to give you the idea how or where we can use structures. Let us look at the example. So the first example, I will write a complex number, complex number. So complex number in mathematics is defined in terms of a plus ib, where I is a imaginary number. So two real numbers are a and b. So where I is defined as root of -1. So if you are familiar with the complex number, then you can understand this. Otherwise, just you can Google it and find out what a complex number is. So complex number is defined in terms of a plus ib. So we need two members, a and b. So complex number is defined in terms of two elements. So that you can group them and define a structure. So here we can define it as a structure, struct complex, and inside that we can have two members. One is a, or I can call it as real part, and second one is imaginary. I can name it as b, or also I can call it as imaginary, that is img. This is the definition. Now you can define a complex number like this, and you can create the variables of complex numbers, and you can use them in your program if you need this complex number. Now next, second example, I'll take an example of a student. Suppose your program is dealing with students' information. So for a student, we can define a structure. A structure for a student may contain the details of a student. So let us say I want to store the roll number of a student, and suppose a roll number is integer type. Next, I want to store the name of a student. So name of a student is a string. So I will have an array of a type character for name. Let us reserve 25 spaces. So it can store a name up to 25 characters. Next thing, I want to store department of a student. So department is also a name. So it's a character type. Let us give the name of size 10. Like computer science or mechanical engineering or anything, you can give a short form of a department name. Next, I want to store the address of a student. So address, I can take it as of some size, let us say 50 bytes, right? So I think it is sufficient. If you want to add, you can add many things like the phone number of a student, email address of a student, date of birth of a student, a lot of things you can add. So that all together forms a single student structure. And when you declare a variable, you get all these things together. And you can access each of them individually using dot operator. So this is another idea of a structure. Now, if I calculate the amount of memory it's taking, like if I say this is 2 bytes and 2 bytes, so this is taking total 4 bytes. And if I take this one, this is integer is taking 2 bytes. So this is character type, 25 characters take 25 bytes because character takes just 1 byte. and this is 10 bytes, and this is 50 byte. So this is 60, 75, 77. So this is taking 77 bytes. So this is another example. This is just for a student. You can define it for an employee. So you can have employee ID, employee name, employee's department, employee address, employee phone number, so on. Then if you want to define a structure for a book, you can give book title, book author name, book version or edition, then year of publication. So you can have all the members. So a lot of data you can combine together under one name. And when you declare a variable of type student, suppose for example, for this, if I do further, then this is a variable I'm declaring, struct student S. So I can say S dot roll number, I can set the roll number. Let us say roll number is 10. Then I can say S dot name, and I can assign some name. Like this, I can access all the member. This is just for one student. So similarly, we can have for various students, and we can deal with their information in our program. So next, one more example for a structure I will take and show you. So next example, I'll take an example for playing cards. A playing card will have some properties. It will have a face value. Let us say kings of hearts. So this is a face value, and this will have color, that is red color, and also shape is hearts. Any playing card can be defined in terms of three properties. First is face value. Then face value can start from 1 onwards. 1 means, let us call it as ace. 1 is ace. Then 2, 3, 4, 5 up to 10. Then a J is 11, and queen is 12, and king is 13. So these are the face values from 1 to 13. The next is shapes are there. So what are the shapes? There are 4 shapes like hearts, diamonds, spade, and clover or club. So 4 shapes are there. So let us define those shapes in terms of codes. We'll give codes for them. Let us say 0 is for club. So this club will be like this, right? And 1 is for spade. So this is spade, all right? Then 3 is for diamond. Let us take it as diamond. And 4 is for hearts. So let us define these as shapes. So for each shape, I have given a number. Then now next thing is color. So as there are only 2 colors, so I will define colors also in terms of codes. Let us say 0 for black color and 1 for red color, right? So 1 for red color. So black and red color. So this is how we can define a playing card. Now this I can represent it as a structure. Let us define a structure. Struct card. What are the members? All these are integers only now. This is integer, right? So all are integer. First one is integer face value. And the second one is integer, that is shape. And the third one is integer, that is color. This is how we can define a playing card. So this is the definition. Now how much space is it taking? Suppose if I say integer is taking 2 bytes, so total 6 bytes of memory it is taking. This is just a definition of a card. Now let us declare the variable. So inside the main function, if I declare a variable of this type structure, so I can have a playing card, struct card, and just C. Now this C, how it will occupy the memory, it will have 3 members. First one is face, and the second one is shape, right? And the third one is color. Now I can access all these members by using dot operator. I can say C dot face assign ace. So for that I will write 1. C dot shape, the shape is suppose 0. So this is for club or clover. Now C dot color, this is black color definitely. So this is 0. So this is how I can create a variable of type structure, and I can initialize its member. So this will be 1, 0, 0. So you can see that I am using dot operator. Now otherwise, let us forget this. Otherwise, I can directly initialize also. Struct card C, I can directly initialize the value. That is, the first face value is 1, and the shape is 0, and the color is also 0. So this is declaration plus initialization. And inside the memory, it will be here, like C will have 3 members, 1, 0, 0. It will be inside the stack that belonging to the main function, or the stack frame belonging to the main function. Now one more thing, I'll just remove this and show you one more thing. See, inside the main function, I want to have deck of cards. So total there will be 52 cards. This is the definition of a card, so just for one card. Now likewise, I want 52 cards. So I can declare a variable struct card. Now this is the structure name. Now variable name, I will call it as a deck of size 52. This will form an array of structures. This is important, array of structure. So I'll be having 52 such structures. So one structure is taking 6 bytes. Total how many bytes it will taking? It will be taking 52 into 6 bytes, right? So 312 bytes it will take. So I'll get 52 different cards. Now each card I can access it with the help of its index. Even if I can initialize this array of structures. So if I want to initialize it, for few cards I will do first card is ace of club or clover and black color. This is first card. Then second, that is card 2, face value is 2, and this is club and color is 0. So on, I can fill this one. Now afterwards, if suppose I want to start filling the other colors, other shapes, like ace of, that is next is spade and the color is 0, right? Then card value is 2 and it is a spade, so next is color is 0. So this is face value and this is shape and this is color. So like this, I can fill up all 52 cards if I want to initialize them. So we can initialize an array of structures like this. This is the first structure, then second structure, then so on. So in this way we can initialize array of structures. If I want to access them individually, like the first card I want to display, then I can use dot operator. So let us print just a face value of first card. Printf %d deck of 0, that is this card, dot face. So it will show face of this first card. Then printf next %d and deck of 0 dot this shape. So I can display shape. That's it. I can display other things also, like colors also I can display. So this is how, by using array name, then the index, then I can access it. So here we have learned how to define a structure, how to declare an array of structure, and how to initialize. If you want to initialize, then how to access the members. So this I'll be giving a demonstration also. This is sufficient right now for the structure. More about the structure, that is pointed to a structure, and the parameter as a structure, we'll be learning them in coming videos.
With definition, you can write R1 here also, right? This is also a variable declaration. Definition, along with that, some variable is also declared. And if you have more variables, you can declare all of them. You can say R1, R2, R3. You can declare as many variables as you have. So this will become a global variable which will be accessible to all the function. This is as good as writing separately struct rectangle and R1, R2, R3. So the same, even you declare them here or you write them separately in the next line. This is the declaration of variable. All right. Now let us remove it from here and put it inside main function. I'll just take one variable, that is R1. Now I want to initialize length and breadth of a rectangle. So you can initialize directly by using the square bracket. Length is 10 and breadth is 5. So length and breadth will have value 5, 10 and 5. So you can initialize it like this. The next thing we will see size of a structure. So already printf is there. I will use this one, remove hello world. I will use printf %d. Then here I will print size of, right? I can write on the structure name, and even I can use a variable name of a structure, R1. Can you guess what could be the size of this structure? Length is integer type and breadth is also integer type. So integer takes 4 bytes, right? In the latest compilers, integer takes 4 bytes. So 4, 8 bytes. See, remember, once again, I am telling you, in whiteboard sessions, I am assuming integer is taking 2 bytes. The reason is I have to draw only 2 bytes on whiteboard, right? If I draw 4 bytes, it will become lengthy on whiteboard. So come back to this. Length and breadth 4 bytes, total 8 bytes. Let us compile and run. So directly I will say run. If there are any errors, it will show here. Yeah, I am getting an error here, that is using namespace is an error. Yeah, there's a spelling mistake here. Using namespace. Now let us run once again. Here I got some warning, but also I got the message. So the output is 8 bytes. Like I said that it will take 8 bytes, so it is taking 8 bytes. But also I am getting some warning. It is saying that the size of operator will give you long unsigned integer. Long unsigned integer here. But I have used percentile D, so it's a warning. Anyway, to remove that, I can give a proper formatting character. So that is LU. Now I will not get any warning. I'll just get the output. That is long unsigned, right? 8 is the answer. So this is the size of a structure. Now one interesting thing I will show you. I will take a character also as its member. So I will just give X, char X. Now total how many bytes of this? 2 bytes for length, 2 bytes for breadth, 1 byte for character, right? So total it should take 9 bytes. 4 bytes plus 4 8 bytes plus 1 9 bytes. Let us run and see what happens. Oh, it is not taking 9. It is taking 12 bytes. Why so? See, the reason is it is easy for our machine to read 4 bytes at a time. So for length it is taking 4 bytes and then reading 4 bytes for breadth. For character also it is allocating 4 bytes, but it will be using only 1 byte out of it. So at a time it will pick up 4 bytes, but use only 1 byte. Alright. See, for example, if you are buying medicine from a pharmacy, so if you want to buy some tablet, just you want 1 tablet, but you have to buy a strip. So it is easy for the sellers or the pharmacy people to sell strips, right? They will not sell single tablet. So you buy 1 strip with the 10 tablets or 8 tablets, it depends on the type of strip, but you will be consuming only 1 tablet. Similarly, our machines can access 4 bytes at a time, but it will be using 1 byte out of it. So for making its accessibility easy, it is allocating 4 bytes for each member. So total is 12 bytes. If you take float, then it will take greater number of bytes, right? Definitely. Don't say that again, sir, it is not taking 4 bytes, it is taking extra. So definitely it depends on the size of the data type. But for character, instead of taking 1 bytes, it will take a nearest bigger size, that is integer. So it is taking 12. And this adjustment in the memory is called as padding. It is called as padding. So inside structures, padding of memory is done. Means it will take extra memory, right? Actual size of a structure is 9 bytes, but it will take 3 bytes extra so that it is easy for our machine, that is processor, to read the entire structure at once. Then later on, it will discard last 3 bytes, right? First 4 for this one, next 4 for this one, and 1 byte for this one. That's all. This was the important thing I have explained you. Now next, let us see how to access these members of a structure. So I will first of all display them, then also I will show you how to access. So instead of using printf, I will use cout. You can use anything. Now you can say it is C++ program. So I will display r1.length, then NL. Alright. The next cout r1.breadth and NL. Let us run. So I should get the values 10 and 5. Yes, I got the values 10 and 5. Now next, I will change the values. How to access the members? R1 dot. See, this is a variable, normal variable. So you should use dot operator for accessing the members. Length assign 15 and R1 dot breadth assign 7. Now I am changing length and breadth. Initially it was 10 and 5. Now I have changed them to 15 and 7. So I should get the output as 15 and 7. Yes, I got the result as 15 and 7. That's it. So this is the demo of structures. So once again I repeat the things I have explained you. how to define a structure, how to declare it, and how to initialize and explain what is padding, then how to access the members. Dot operator is used for accessing the members. So you can write down if you are opening a project of C++, you can write down the code in C style as well as C++ style. Structures are available in both the languages. So that's all in this video. I suggest you go online and practice this one. So that's all.
In this video, we will learn about pointers. So first of all, I'll give you definition of a pointer, what does it mean by pointer, and why we require pointers. Then I'll show you how to declare and how to initialize, what does it mean by dereferencing, and we'll also learn about dynamic memory allocation. So let us start with the definition. See the definition of a pointer. Pointer is an address variable that is meant for storing address of data, not data itself. Normal variables are data variables, but the pointers are address variable. And pointers are used for indirectly accessing the data. So the question is, why do you need to access indirectly? So let us understand why actually we need pointers. Then we will see how to declare and use them. So first of all, see this picture, again I am drawing it here. See, this is the main memory, right? And this is the CPU which will execute our programs. So how this main memory is utilized, already this picture we are following it. This is divided into three parts. Here actually our program resides. So I am writing main function. It may be having more other functions. Now this area, see, this is a stack. So actually stack will be on the top, right? But I am showing it here. Then the other part of the memory is heap memory. So the main memory is divided into three sections and utilized. This is code section, right? This is code section, and this is stack, and this is heap. So code section, and this will be stack and this will be heap, but I usually show here as a stack so it's easy for understanding. Anyway, there are three portions of memory: code section, stack, and heap. So the program will utilize the main memory by dividing into three sections. So this program can directly access these two areas. What are those? Code section and stack. Program will not directly access heap, right? The policy of a program is it will not directly access it. So heap memory is external to the program, outside the program. So program doesn't directly access. Then how to access that? For that it needs a pointer. Yes, one of the reasons of using pointer is accessing heap memory. So program should have a pointer with itself, and with that pointer it can access anything in the heap. So I may have an array or anything inside heap, and the program can access that. So for accessing this memory from the program, we need a pointer. So pointer is useful for accessing the resources that are outside the program. So this is one example. Heap is one thing. Then if suppose on the hard disk there are some files. Now for accessing a file, program cannot access this hard disk files directly because hard disk is external, or files are external to a program. So for that it needs a pointer for accessing, and that pointer should be of file type, and we can access that file. Then a program may be accessing a keyboard, a program may be accessing a monitor, a program may be accessing internet or network connection. All these things are external to a program, so all these things can be accessed with the help of pointers. So one major usage of pointer is accessing the resources which are outside the program. So I will list it. See, pointers are used for accessing heap memory, right, and for accessing resources. And third, pointers are used for parameter passing also. Parameter passing. This I will be explaining afterwards, how pointers are useful for passing parameters. So these are the major usages of pointer. Accessing heap, which is like a resource, accessing other resources, or parameter passing. So now next let us learn how to declare a pointer, how to initialize, and how to use it. So by taking some small example, I will show you. This is a data variable. I am declaring A and also initialize it, right? So this is a data variable. Normally we declare variables like this. Then second thing, pointer. This is an address variable, right? This is an address variable. So address variables are called as pointers in C, C++. It is a data variable. Normally we declare the variables like this. Suppose this is inside main function. I am writing it as a function, okay? So this variable, it will occupy the memory inside the stack frame of a main function inside the stack, like it is having value 10. So if I draw it a bigger picture here, so like this is there. Suppose this is taking 2 bytes, integer is taking 2 bytes. So its addresses are 200 and 201. There are 2 bytes in which this value is stored. One is 200, other one is 201, right? So 2 bytes. See, that is the reason to show only 2 bytes, I am saying integer is taking 2 bytes, right? So 2 addresses. Now, this is a pointer. This pointer, I will initialize it. So I will initialize it in the next line, p assign ampersand a. So this will store the address of a. So what is this p? P will also occupy memory. Pointer is also a variable. This will also occupy memory. So this is created inside the stack frame of same main function. If I show it diagrammatically, it looks like this. This pointer will also take 2 bytes. So let us say the address of this pointer is 210 and 211. Just I am assuming random number. Okay, don't confuse that the next should be 202. So whatever it may be, I am saying it as 210 and 211. Now when I say ampersand a, this will have the address of this variable. So it is pointing to this one. So here inside the memory, if you see, it is pointing to this one. So that pointer is pointing there, right? Now focus on the syntax. This is a variable. This is a pointer variable. This is initialization. Address of a variable is given to P. Now I want to access this 10. So I want to print. So I can say printf %d a. So this will print value 10. Now I want to access same thing by using pointer. So from pointer I want to access it. So again I will say printf %d, and if I say P, it will be taking 200, but no, I want this data. So say star P. So this is declaration and this is assignment or initialization, that is it is initialized with some value, and this is dereferencing. This portion is dereferencing. So when you are dereferencing, you have to use star, and when you are declaring, you have to use a star, and initialization directly we can write P. So you have to get familiar with the syntax: declaration, initialization, dereferencing. So this is how I have already taken a data variable and making a pointer point on it. In this example, I am not using pointer to access that heap memory, right? Next, I will show you how to access heap memory using a pointer. I will declare a pointer variable. First of all, this is a pointer variable. So this, whenever you declare something, that definitely takes space in stack or stack frame of that particular function. So P is created here, right? Whenever you declare, it will be inside stack. Remember, every variable declare. When you declare a variable, it will be inside stack. Now, I want to allocate memory in heap. So I want to create an array of size 5 in heap. So how to get memory in heap? In C language, the function name is malloc. When you write malloc, then only you will get the memory in heap. So here I will write down malloc function, malloc, malloc. So for this, I have to include some library, that is #include stdlib.h, right? stdlib.h. Now I can use this function malloc. Now here I should mention the size. So malloc function take the size, how much memory you want. So you have to mention in terms of bytes. So I want 5 integers. So 5. Then what is the size of the integer? We are assuming it as 2 bytes. So let us compiler decide it. See, as we are assuming, but it may be taking 4 bytes or 2 bytes. So let the compiler decide the size. So we can use the operator called as size of operator, and to that operator I will pass int. So it will give the size of an integer. Size of integer, if it is 2 bytes, then 2 into 5, total 10 bytes of memory, this malloc function will allocate. So it will allocate total 5 integers, right? Now that memory is allocated. Suppose the starting address of this is 5000, for example. First byte address is 5000, so on. Then that should be pointed by a pointer, because we cannot access it unless we have a pointer. So I will assign this to a pointer. Now this malloc function returns void pointer, so we have to typecast it and say it is integer pointer. Now this line will allocate heap memory. Remember, whenever you say malloc, then only it will allocate in heap. So this P will be pointing on this one. So P will get the address 5000. So it is just like something is there in heap. Now pointer is holding it, right? It is just holding one edge of that array, that is 5000. Now using that pointer, we can access that entire array. So this is how heap memory is created. And how to do the same thing in C++? So just we have to say new. New is an operator in C++ of type integer and say size 5. So in C++ it is very simple. This is C++ and this is C language. C language syntax is little lengthy and C++ is very simple. So while explanation I may be writing new most of the time, right, on whiteboard, but actually in C language I have to use malloc function for allocating memory in heap. So this is how pointer is used for creating heap memory. So this was the introduction of a pointer. So in the coming videos we will see how to have a pointer upon an array and how to have a pointer upon a structure. We learn about all these things.
So P is a pointer, so it can store the address. If you want to use ampersand, then you should say a of 0 means this is 2, a of 0 is 2, and its address. Then you should write ampersand. So you have two options. Either you write ampersand a of 0 or just write a. Okay, just write a. Don't write ampersand a, it will be wrong. It is invalid syntax. Compiler may or may not give any warning for you, so you may not get proper results. So don't use ampersand a when you are initializing a pointer with an array, right? So just take a. Then, can I access all these elements using pointer? Yes, you can access all these elements using pointer to an array. So I will print all the elements using a for loop for I assigned 0, I is less than 5, I plus plus. Then using cout, I will print all the values a of I. So let us see, and also I will give adl so that they appear in new line. So let us see the output. Yeah, here we got the values 2, 4, 6, 8, 10. I have printed all the values using a. Now how to access them using pointer? Just say p of a, p of I. So in place of array name a, can I use a pointer? Yes, you can use it. It will act just like the name of an array. So in case of arrays, pointer acts as name of an array. Now I'm executing it. Yes, using p also, it is printing all the values. So p is a pointer which can act as a name of an array. Yes, this is interesting. So pointer to an array. Where the array is created, it is created inside the stack. Remember, once again I am telling you, whenever you declare anything in your program, it is going to be created inside the stack frame for that function. So it will be created inside the stack frame of main function. Now next thing, let us create an array in heap. So using a pointer you can create an array in heap. So I will remove this, and this is also gone. Now we have a pointer. Now to this pointer we can assign a array created in heap. So for that I should use malloc function and 5 into size of int. This is what I have explained on whiteboard. So malloc function, for malloc function I should include stdlib.h also. So malloc function will allocate the memory for 5 integers. So it's an array of integers and it is assigned to a pointer p. So you can see that only p is inside the stack, but this array of 5 integers is in the heap. Now I will initialize all the values. I have only 5 values, so I will initialize them. First value is 10 and p of 1 15. Okay, then p of 2 is 14. I will just randomly assign some values. P of 3 is 21 and p of 4 is 31. Then here I am printing, so it's an array. When we have allocated 5 integer means it's an array. So I am assigning all 5 elements, then I am printing them. So I will get all these values printed, and this array is created in heap. So let us run and check. Here you can see that all these values are printed here. So this is a array inside heap. Now I will show you a C++ method of doing it. So instead of using malloc, we can just say new int of size 5. This is very simple in C++. Now this 5 what integers, so it's an array, 5 integers, right? And then it will automatically convert into integer pointer and assign it to p. So it is acting just like malloc function, but the syntax is simple in C++. Alright. See, I am using mixed code of a C and C++. So you can write down the C language code inside C++ programs also. And once again I am telling you, if you know C++, so you already know C language also. Alright. So let us run this and check. So using C++ syntax also, I have created an array and initialize all the elements, then I am printing them. So this is C++ syntax. Now the next thing about dynamic allocation. See, here we have dynamically created the memory for an array in heap. So by using new, we made a request for memory in heap. So when we have finished using it, we should also delete that memory, because we are creating an array here. So we should use square brackets, opening and closing square brackets. These are, I will give a space so that you can see it. Delete, opening and closing square bracket, and then p. If it is any other type of variable, then you can just write that variable name. If it is an array, then you must write down this subscript, right? So remember one thing, whenever you are dynamically allocating memory, you must release the memory by the when you have finished using it. And if you are using C language, then you have to say free p. Free is used in C language, delete is used in C++, right? So this is for deallocating the memory that is allocated in heap. So heap memory should be deallocated. And one more thing, as the program is very small, the moment you run, it will execute few steps and finish. So in such programs, if you are skipping this, it's not a big problem, right? If you're skipping the deletion part, then it's not a big problem. So mostly in students size programs, like the programs that we'll be doing in this course, are small programs. They are not big projects. In the projects, this is very crucial thing. You must handle it very carefully. When memory is not required, you must delete the memory, right? For these small practice programs, you can skip them, right? Even when you do data structures, then there also it is good if you are deleting it. And if the program is very short, then if you skip, then it's not a problem, because once the program ends, the heap memory will be automatically deleted, right? It will not be there once the program ends. Now the next important thing about a pointer. See, first of all, I will write down some code here, then I will explain you what is that. So I have removed that code. See, first I have a pointer of type integer p1, and then I will take a pointer of type character, and also I will take a pointer of type float, then also double p4. Okay, there's a pointer, and also I will take one pointer of type structure. I have defined a structure here, and then I will take a pointer of type structure also, struct rectangle star p5. So I have 5 pointers. Now I will print size of p1, that is pointer p1, size of the pointer. Then I will do the same for all the pointers. So I will copy this. Now I'm printing the size of all the pointers. Now the interesting thing is, I have different type of pointers and I am printing their sizes. So integer pointer should take 4 bytes, right? Character pointer should take 1 byte, right? Because character is 1. Float pointer should take 4 bytes, right? Because float takes 4. Let us check. Oh, it is showing 8888. So every pointer size is 8 byte. I was thinking 4 byte, 1 byte and 4 byte. No. Yeah, this is the interesting thing. Whatever the data type of pointer is, pointer takes same amount of memory. Every pointer takes same amount of memory. You can see that all these pointers are taking 8 bytes. 8 bytes, right? So whatever the type of pointer may be. In the latest compilers, the pointers are taking 8 bytes. Earlier, they used to take 4 bytes, that was equal to integer size. But in latest compilers, they are taking 8 bytes in 64-bit machines. So whatever the type of pointer is, it is independent. Size of a pointer is independent of its data type. That's it. This is the important thing and the interesting thing about pointer. So that's all in this video. I suggest you practice all these things so that you get used to with these things. Don't simply watch the lectures. Try to practice everything, right? So this will help you further in the course. So that's all.
In this video, we will learn about reference. Reference feature is available only in C++. This is not a part of C language. So let us understand reference. A reference is a nickname given to a variable or memory. Let us say 200 is the address and 201 2 bytes and value 10. Now what is the address of A? 200. What is the address of R? That is also 200. So it means if I print using cout A, I'll get the value 10. And if I say R++, then this means this value is increased to 11 because the same value is R now. So address of R is also 200. If I say cout R, then it will print value 11. So the same value. If I again say cout A, then I'll get same value 11. So a reference is nothing but another name to a variable. Now the question is, why do you need another variable to a same variable when you already have with the name A? Why do you want another name R? So basically this is useful in parameter passing, and this is very useful feature of C++. For writing small functions, we use references instead of using pointers. So when we learn about the parameter passing, that time I'll explain you what is the usage of reference. Right now in my example program, if it's a simple main function, in this I don't need reference because already I have A, I can use A. But for explanation, I have used the simple code. What a reference means. A reference is nothing but another name given to a variable. So the actual name is A and this is alias of, so R is just another name of A. Now that's it about reference. So what is reference, how to declare it, and how to initialize it, I have explained. Now what is the actual purpose of reference? We will see that in coming videos where I will talk about functions and parameter passings. So that's all in this video.
Initialize, declared and initialize. Now I want to access these members using that pointer. So how I can do that? Can I write, I want to modify length to 20 suppose. So can I say p dot length assign 20? No, p is a pointer, it's not a variable, it's not having members. Then do what? I have to come here, then I can access these members. So go to the place where pointer is pointing. Suppose the starting address is 200, then it is having address 200. So go to address 200 and access data. So okay, so I should write asterisk. Okay, I wrote asterisk. But this is wrong because the higher precedence is for dot operator. So first it will take it as p dot length, again it is wrong. So I should enclose this inside the bracket. So this should be inside the bracket, then dot. Oh, so much I have to write on for accessing that member. So instead of following this syntax, C language gives a simple syntax for accessing the members using pointer. So I can simply say p arrow length assign 20. So either we can use this or we can use this. So finally, for a normal variable, use dot operator, this dot operator, and for pointer variable, use p arrow, right? Instead of dot, we have an arrow. So this is the method of accessing a structure using pointer. Arrow is used. Now next, one more thing I will do. I will create an object dynamically in a heap using pointer. So I will create an object or a variable of type rectangle dynamically. So I'll remove this and I will write on the code. Now let us see how to create it dynamically. So for that, first of all, I need a pointer. So I will take a pointer of type structure, struct rectangle and a pointer. So I am using letter P for a pointer. So this P is a pointer. So this will be created inside the stack. Now already you are familiar, when you declare the variables, they are created inside the stack as a part of code activation record of function. So yes, it's a variable, so it's inside the stack. Now we want a variable of type structure, object of type structure in heap. So how to get the memory in heap? Malloc function, yes. So I should call malloc function, yes, malloc function. Then I must give the number of bytes that I require. So actually it is same as this structure size. So I can mention 4 or else I can say size of struct rectangle. So rectangle structure is taken, right? Then this will allocate the memory. Now we have to typecast it because malloc function returns void pointer, right? So void pointer means it's a generic pointer. So I have to typecast it. So for typecasting, I should write down here struct rectangle asterisk. So I am typecasting it as a rectangle type structure pointer, then assign it to P. This is how we can allocate a object of type this rectangle in heap. So this will be created in heap and it will be having length and breadth and the pointer will be pointing on that one. This is the method. Then I want to access the member, so I can use arrow operator. So P length assign value 10 and P's breadth assign value 5. So this is how I can assign length and breadth. So this will be 10 and this will be 5. That's all. So more if you want you can write down. I have to show you how to create a variable of type structure in heap by using malloc function. So that's all about a pointer to a structure. So in the previous example I have shown you an existing variable to the pointer was pointing there, but now this is a dynamic object created in heap and the pointer is pointing there. So that was static object and this is a dynamic object. That's all about pointer to structure. In the previous whiteboard lecture, I have explained about pointer to a structure. So let us look at the demonstration for the same. So already I have written a structure here. Alright, structure rectangle with length and breadth. Now here I will declare a variable of type structure. Struct rectangle R. And I will initialize length and breadth with 10 and 5. That's what I have done on whiteboard. I will try to compile the program. I mean run the program. There is nothing to display, but it will run without any errors. Yes, there are no errors. Nothing is displayed, right? Now one thing I will show you. This is a C++ program, right? Inside C++, if you remove struct also, it is valid. I'm using C++ compiler. Inside C compiler, you must write struct here, right? But in C++, you can script struct here. Just you can write rectangle. Let us run. If there is an error, then it should give an error message. Undefined rectangle, it should give a message, but no error. There is nothing to display, so nothing is printed and there is no error, right? So it means in C++ programs, struct is not mandatory. In C programs, struct is mandatory. This is the difference. All right. Now let us proceed further. This is a object of a rectangle, right? So if you want to access length and breadth, then you can access cout r dot length. All right. So it will print length, and this is NL. Then cout r dot breadth. So this will print breadth. This is a normal access using dot operator. So when you have a normal variable, you access them using dot operator. Remember this one, right? Now I will take a pointer. So for pointer, again I can write just rectangle and star P. To this I will assign the address of a object of type rectangle. Now when you have a pointer to a structure, then dot operator cannot be used. You have to use arrow. You have to use arrow. Then cout, I will use arrow, P arrow length, okay. Then this is NL. Then cout P arrow breadth, and for this also I will use NL. Let us run this. It should print length and breadth, that is 10, 5 in this line and 10, 5 in this line. See, for normal variable like that is rectangle R, use dot operator, and when you have a pointer pointing to a structure, then use arrow. All right. So remember this. Don't get confused when to use dot and when to use arrow. Just a variable, use dot, and for pointer use arrow. This is a pointer, right? So I got values 10, 5 and 10, 5 here. Then next thing I will show you how to create an object of rectangle, that is this rectangle structure, in heap. So I will remove all these things. Okay, I will remove these things now here. So first of all, you need a pointer, and when a pointer is declared, it will be created inside stack, right? Now how to create an object of in heap? So for that, in C language, you have to write down struct rectangle and pointer, call malloc function. Malloc function should take the size of struct rectangle. So what does it mean? Malloc function will allocate the memory. How much memory? We want total bytes of memory that are consumed by this rectangle object or a structure. So total 4 plus 4, 8 bytes, right? Like on whiteboard, I was assuming it was taking 2 bytes, but compilers take 4 bytes for integer. So total 8 bytes of memory. So size of operator will take 8 bytes, and malloc it will become 8, right? You can directly write down 8 also here. Then malloc function returns a pointer. So it is of type void. So we should typecast it as struct rectangle. So here a rectangle object will be created in heap and the pointer will be pointing on it. Now using a pointer, I will set the length. I will set the length as 15 and set the breadth, that is 7. Now you can see that I am using arrow operator because I have a pointer to a rectangle structure, right? And again I am printing them, so I should get the values 15 and 7. So this is a C language and C++ syntax mixed. If you write printfs here, this becomes a C language program completely, right? So if you write struct and then here printfs, this will become a C code. So you can mix C and C++ code. So let us run it. See, I got the values as 15 and 7. So it is printing 15 and 7. So that's it. This is dynamic allocation of rectangle structure. If you want to do it in C++, then just it is easy. You have to write just new rectangle. That's all. You don't have to write malloc, size of, all those things. Just change this line and it becomes a C++ code and it will create a rectangle object in heap. Alright, so there's a difference between C code and C++ code. So we have seen both C language code as well as C++ code. I will run this one. Yeah, it's working. I got the result as 15 and 7. That's it. See, once again, I am telling you that I am taking a C++ project. So the type of project is C++, where I can write down C language code also, C++ code also. So whichever one you are comfortable, you follow that one. Alright, if you're comfortable with printf and malloc, use that. Or if you're comfortable with cout or this new, then use it. Alright, so there's a minor difference between the style of code in C and C++ here. So I suggest you to practice this and see it by yourself. So this will be helpful for you further. That's all in this video.
In this video, we will learn about functions. So I will explain what are functions, then I'll explain what is parameter passing and what are the different methods of passing parameters like pass by value, pass by address, and pass by reference. In C language, we have only pass by value and pass by address, but in C++, we also have pass by reference. So I will take some simple example and explain all these parameter passing. So let us start with functions. What are functions? Function is a piece of code which performs a specific task. We have already studied about structures. In structure, I said that structure is a group of related data members. Now, function is a group of related instructions which perform a specific task. So, grouping data is a structure. Grouping instructions is a function. Functions are called as modules or procedures. See, instead of writing a single main program, writing everything inside the main function, we can break the main function into small manageable size pieces and we can separate the repeating task or smaller task. For example, if I am writing one program, so everything is going to be inside main function. So let us say these are the instructions in main functions. I may be writing thousands of lines of code inside the main function. So this is not a good style of programming. Writing all the lines inside single main function, it will be very huge to manage and it's very difficult to develop. So if we find that this program can be broken down into smaller tasks, we can break them in the form of functions. Like suppose first function, function 1, it may perform some task, and another function, function 2, and this is performing some task, and similarly function 3 I can have and performing some task. So I can break this larger task into smaller simple tasks and then I can use them all together inside the main function. Suppose here I have main function, then inside the main function I can call these functions. So function 1 and function 2, function 3. So for example, I have taken these three functions. For example, I am explaining like this. So here you can see that if I combine all together, everything is there inside the main function. Main function is utilizing these functions. So that will sum up to a similar program. If we follow this style of programming, this style of programming is called as monolithic programming. Write everything inside a single body. So this is monolithic programming. This is monolithic programming. Now, breaking a program into smaller pieces of functions and using those functions inside the main function, that is integrating them all together, this is another style of programming. This is called as modular programming or procedural programming. It's modular programming or procedural programming. So this style of programming is called as modular or procedural programming. So this is easy for developing. You can break the program into smaller tasks and you can focus on smaller tasks and finish them and make them perfect. It's easy for one single individual to develop the application. Even you can break this software project into a team of programmers. Now, if you follow this style, then only one person has to develop this one. If you follow this style of programming, a group of programmers can develop a single application. Like some people are developing some function, like one person is developing this one, second person, third person, and one of the person who's a team leader can integrate all of them inside the main function. So this style of programming has increased productivity and also a reusability. Like if suppose I need function one more time, so I can call it again. So instead of writing the same code again, like suppose these three lines are performing some task and these three lines are performing the same task. So instead of writing it two times, I can write the function one time and I can use it two times. So this is reusability. And the same function can be used in other software project also. So you can put the group of functions together in a library also. So these are the benefits of functions, just to name few. So C language is a procedural or modular programming language. So this is the topmost feature supported by C programming, which is also there in C++ also. C++ is beyond this one. C++ follows object orientation, right? Where you group the related functions together and put them in a single class. So we will learn about it in the coming videos. So right now, let us focus on modular programming. So we can break a program into functions. Now, let us write a simple example function and learn how we can separate the task from the main function and what are parameters. I have a small function, example function. I'll explain something about this. See, here is a main function. From here to here is a main function. Now, in this, I am performing a very simple task, that is, I want to add two numbers. So, I have three variables, x, y, z, and x and y are having some values. Then, I want to add these two values. So, even main function, I can add it. Just I have to say x plus y. But I prefer, instead of adding inside the main function, let it be done by some other function. So, for adding two numbers, I am writing a function. Right? So as I said that instead of writing everything inside main function, you can separate the logic and write functions for performing smaller tasks. So we are looking at addition function. So this is a add function which will add two numbers and returns the addition or the sum of two numbers. So let us see how this function is. See, this function is taking two values a and b, and locally it is having its own variable c, then adding these two values and storing the result in c, and it will return the result, right? So it will take two values. This function needs two parameters. It will add them and returns the result c. So if we see in the main function, back to the main function, here I am calling add function. This is a function call, and I am passing two parameters x and y. These values will go into a and b. It will add them and return the result. That result will come into this z, and then it will print this value z. So as per this example, it will print the value 15, right? Now let us learn some terminology. See, this is the prototype of a function or header of a function. Prototype, this is called as prototype, or it is called as signature of a function, right? And this is a declaration of a function. Then this body is there. This is called as definition of a function or elaboration of a function. So this is declaration and definition of a function, and this is function call. We are calling the function. Now, what are parameters? See, here we are passing these two values x and y to this function which is taking two parameters. So these parameters, the one which we are passing, these are called as actual parameters. These are called as actual parameters. And these parameters which are taken by this function, these are called as formal parameters. So these are formal parameters. Now let us understand the working once again. This is a main function. Program starts from here. Starting point of a program. Three variables are declared. Values are assigned. Function is called. So the control goes here. And when the control is transferred, the values of actual parameters are copied in formal parameters. So x value, that is 10, is copied in A, and 5, that is y value, is copied in B. Then in C, the addition of the values is done. This is 15, and 15 is returned. And when the function returns, it will come back to the line from where it was called. So the result of the function is 15. So this becomes 15, and that 15 is assigned to z. So z becomes 15, and the value is printed. So this is the working. So I have explained you the parameters and have explained you the working. Now let us see how it works inside the main memory. Inside the main memory, this is the code section area. Inside the code section, this is the function add, and this is the machine code of that add function, and this is the main function. This is the machine code of the main function, right? So let us see in detail how the program works and how the functions are utilized. Now the program starts from here. First of all, three variables are declared. So inside the stack, that is inside the activation record of main function, three variables are created, that are x and y and z. Three variables are created. Then first variable assigned with value 10 and second with 5. So this is 10 and this is 5. Then function add is called. Once the function add is called, its own activation record or stack frame is created, and it will have its own variables that are A, B, and C. These two parameters and local variable. Now the value of x, that is 10, is passed here, and the value of y, that is passed here. Then it will add these two numbers, so the result is 15. Now next line is returning. So when it is returning, the value of that C is copied in Z, because here in this line you can see it is copied in Z. Then once the function ends, it will come out and return back to this line. So this activation record is deleted. See, it is just like this. From here, if you see, suppose from here the main function has called add function. So the control goes to add function. And when it's executed, when it finishes, this activation record is deleted and the control come back to the main function here. Then it will print this one. So suppose those lines are for printing. So it will print this value 15. So this is how it happens inside the main memory when you are writing the function. So the benefit of function is that the function will have its own activation record. Its separate set of variables will be there inside the memory, and when it is called, they are created. When it is destroyed, when that function terminates, they are destroyed. And one more point about this one is, this function cannot access the variables of main, and main cannot access the variables of add function, right? One function cannot access the variables of another function. It means that I cannot use xyz here inside add function because they belong to main function, and I cannot use abc inside main function because they belongs to add function. So that's it. This is about the function. Let us look at the things once again quickly. See, I have shown you how to define a function. This is the prototype of a function and this is the body of a function. These are the parameters. They are called as formal parameters. And this is the function call. These are actual parameters, right? That is the one who is calling, its parameters are actual parameters. And how the function calls are made, this is there inside the memory. So that's all. Now in the next video, I will explain parameter passing methods. So the three methods, we will see them together by taking some simple example. In this video, I will explain parameter passing methods. Like there are three parameter passing methods: pass by value, pass by address, and pass by reference. So for explaining all three, I have taken one simple example, that is swapping of two numbers. I have a function for swap. So let us understand all these three methods. So first is pass by value or call by value. This example is based on call by value. Let me explain you the example first of all. So this is the main function having variables a and b with values 10 and 20. So these are the variables of main function having values 10 and 20. Then it is calling swap function. Swap function. This swap function is taking two parameters x and y, and it is swapping the numbers x and y with the help of a temporary variable. And then when the control come back to the main function, it will print the values of a and b. So this is the code, main function and swap function. So here in the diagram, I am showing the variables of main function a and b, and these are the variables of swap function, that is x, y, and temp. And inside the main memory, this is the code section where our program is residing, and these are the stack frames or the activation records of main function and swap function. When the function swap is called, this activation record will be created and deleted when the function ends. So for explaining the working, I have taken these diagrams. Now let us understand call by value and understand its working. Now call by value. See here, the main function is passing these parameters. These are actual parameters. And these are formal parameters, x and y. What happens when the function is called? The value of a and value of b. A is copied in x and b is copied in y. So 10 is copied here and 20 is copied here. So the formal parameters are normal variables. So they will take the value of these parameters. They will take the value, right, when the function is called. Now this function, as I am not returning anything, it is void type. Now this is the logic for swapping the values. X and y are swapped, so with the help of temp. So first line temp assign x, so this will become 10, and then x assign y, so this will become 20, and then y assign temp, so this will become 10. You can see that the formal parameters are modified, but actual parameters remains same. So the swapping is done inside the variables of swap function only. They are not reflected inside actual parameters. So when the function ends after this line, when it comes back here, there is nothing written, it is void type, then print. So a and b are printed. So what are the values still? 10 and 20. So these values are not swapped. These values are not swapped. So I'll get the same values, 10 and 20. So if you see here, these 10 and 20 were there, and these 10 and 20 were passed, and with the help of temp, this became 20 and this became 10. But actual parameters, they are same only. So this is pass by value. In pass by value, any changes done to formal parameters will not reflect in actual parameters. So when you should use pass by value? When you don't have to modify actual parameters, you can use pass by value. And you can use pass by value if a function is returning some results. So swap function should not be written using pass by value. In the previous video, we saw adding two numbers. So that is suitable for pass by value. So pass by value can be used there. But here, pass by value is not suitable for swapping two numbers. So anyway, we have learned what is pass by value. So in pass by value, actual parameters will not be modified if any changes are done to formal parameters. Next, I will show you call by address. Now let us look at call by address. So in call by address mechanism, the addresses of actual parameters are passed to formal parameters, and formal parameters must be pointers. Any changes done inside a function will modify actual parameters. Now here we have to learn two things: how to write call by address and how it works. So remember, call by address uses pointers. So let me write down the syntax. So you have to observe the syntax very carefully. This code is same as call by value code, right? Now how to convert it into call by address code? So what are the things I have to do? So here inside the main function, when I am passing these parameters, these are actual parameters, so I should send there addresses. So these are the addresses. So the first thing. So it means I am sending 200 and 202. Now who can take addresses? We know pointers can take addresses. So these must be pointers. Yes, these are the pointers. Right? So it means when I pass from here the addresses, 200 will be copied in this one and 202 will be copied in this one. So when the function is called. So it means this is pointing on this and this is pointing on this one. Yes, those are the pointers. Now here inside the code, as this is a pointer, if I say just x, it's 200. So this will be 200. No, I am talking about this, the value here, that is 10 and 20. So I am talking about the value. So here I should say asterisk and asterisk x, asterisk y, and here also asterisk. So these are the changes we have to make. So first I wrote a simple code of call by value, then I made it as call by address. So in call by address, the formal parameters must be pointers, and here I have to use dereferencing, that is asterisk, for accessing the data of actual parameters. And here addresses must be passed. So these are the changes in the syntax. So you should observe the syntax very carefully. Now I will show you the working. Let us start and executing the program. See, first the main function is having two variables a and b. They are having value 10 and 20. So these are 10 and 20. Next, the swap function is called. The addresses are passed. So these are the pointers, so they will take the addresses. So here in the diagram, if you want to see, these are pointing on this one. They are having their addresses. So now this function can access the variables of another function. It's not directly, it is indirectly using pointers. Yes, one function cannot access the variables of another function directly, but it can access using pointers. So it can access indirectly. Yes, this is indirect access. Now, when the function is called temp is already there. Temp assigns star x. So star x, asterisk x, so that is 10. If you say x, it is 200. Asterisk s, it's 10. So 10 is stored in temp. Asterisk x assign asterisk y. Asterisk x 10, asterisk y 20. So this is copied here. 20 is copied here. Then asterisk y assign temp. Asterisk y is this one, assign 10. So temp is 10. So it is 10. Now you can see that actual variables are modified. So when the function ends, a control come back, and when it prints, the value of a is 20 and the value of b is 10. So this is 20 and this is 10. So yes, these are swapped. So call by address is suitable mechanism for modifying the actual parameters. So we will be using this type of code more frequently in our programs. So you should be familiar with this one. Call by address is more useful. So that's all about call by address. Now the last thing is call by reference. Now let us see call by reference. For call by reference, I have written back the same example. Now this is called by value parameter passing method. Now what are the changes in this I should do so it becomes call by reference? So what is a reference? Already we have learned in the previous video, and references are supported only in C++, right? This is not a part of C language. And this is a very useful and powerful mechanism or feature of C++. So here you have to learn two things: how to write call by reference and how it works. So first of all, how to write call by reference. Let us look at the code. Here inside the main function, I have two variables a and b are passed. So this is call by value, right? Nothing is written here. There's not ampersand or anything. This is call by value. And here, these are also normal variables. So this is call by value. And this is normal code. So same as call by value. How to make it call by reference? Let us see the changes. Here in actual parameters, don't do anything. Don't do anything. And inside the body, don't do anything. Same as call by value. Only in the parameters, just before a parameter name, variable name, write ampersand. So simple syntax. Syntax is very simple. Just write ampersand there. Those are references. This is a reference to A. This is a reference to B. Y is a reference to B. Those have become references. And how do you use references? Normally like other variables, normal variables. So normal variables, those are normal variables. So syntactically, this is call by reference. See, it's not a major change. Compared to call by value, it is similar. Just we are having ampersand there. Now, working, how it works. See this. Let us start. Program start from main function. A and B are two variables, okay? Then A is having value 10, B is having value 20, A is having value 10, B is having value 20. Swap function is called by passing A and B. A and B are passed to X and Y. X becomes a reference to A, Y becomes a reference to Y. Reference is nothing but alias or another name or a nickname to a variable. So this itself is X and that itself is Y. So does it take any memory? References doesn't take any memory. Existing variable, another name is given. Yes, so that doesn't take any extra memory. So these 4 bytes, 2 bytes for integer, 2 bytes for integer, same 2 bytes. So these 2 bytes are called as X and that's 2 bytes are called as Y. See, these variables actually belong to main function. Main is calling them as AB and swap function is calling them as XY. Yes. So swap is calling with another name. Now let us continue. Temp variable is declared. Okay, temp is also declared. Temp is also declared. Then temp assign X. So X value is stored in temp. Then X assign Y. So this becomes 20. Then Y assign temp. So Y becomes 10. Function ends. Control come back to this line. Print what are A and B? 20 and 10. So 20 and 10. So you can see that when these formal parameters X and Y are manipulated, the actual parameters are modified. So that's it. This is called by reference. Now one important point. I said that one function cannot access the variables of another function directly. It can access indirectly. But how it is possible that it is accessing directly? So the answer to this is, if you see inside the memory, swap is not a separate function. Swap is not a separate function. It has become a part of main function and there is only one activation record. So if you see the working of the same program here, now as long as the main function code is running, these are A and B. And once the swap starts, these are called as X and Y. And also temp variable is created inside same code activation record of main function, right? Inside the same stack frame. And once the main swap function ends, this is gone and the values that were 10 and 20, these are changed to 20 and 10. So this swap is not a separate body of a function. It has become a part of main function. So it means the machine code of this swap function will be pasted here. So this is more like monolithic program, right? The entire code inside single main function only. So the machine code is monolithic, though the source code is procedural or modular. So yes, C++ does this one. C doesn't do this. C++ allow call by reference and the code of that function will be copied at the place of function call. So do you think this should be allowed or this we should entertain that code is copied there? So what is the use of writing function? So yes, this is not advisable to use call by reference more frequently. You can use call by reference for small function, 1 or 2 lines of function or the function like the swap. You can use call by reference, but don't use it for heavy functions which are having loops and all, having complex logic. So call by reference should be used carefully. So it's a more powerful feature of C++, but it should be used carefully, right? It cannot be used always. So that is the reason C++ also have call by address. So more commonly used features are call by value and call by address, right? So that's all about parameter passing methods. Then in the coming videos, I'll show you how to pass arrays to the function and how to pass structures to a function.
How they are working so that it is easy during the course.
In this video, we will see array as parameter. So already I have an example, and here I will show you how arrays are passed as parameter, and more about arrays we will see. See, here is a main function. Main function is having an array of size 5 and also it is initialized. So this is a part of main function array and its name is A. Now here I am calling a function fun by passing array and the number of elements, that is size 5. And this function fun, it is taking parameter array A, and for passing array as parameter we have to mention empty brackets, right? We should not give any size. And this function doesn't know the size of an array because array actually belongs to main function. So we should also pass what is the size of an array, means how many elements to access. So this A is actually like a pointer to an array. It's not an array itself, it's a pointer to an array, and this is number of elements. Now in this code I am just printing all the elements of an array. This for loop is printing all the elements of an array. Now the important thing, let us see what is the parameter passing method used here. See, array is passed by address. Arrays cannot be passed by value at all, whether it's C language or C++. Arrays can be passed only by address. So it means the address of this array, the base address of this array is given to this pointer. This is just a pointer, and giving the bracket means it's a pointer to an array. And what about the next thing, that is 5 is passed here. So this is which type of parameter? If you see this, there is no asterisk, so it's not called by address. There is no ampersand, this is not called by reference. Yes, it is called by value, just a normal variable. So this is called by value. So there are two parameters, one is passed by address, other one is passed by value. So this is its own local variable n. So the value 5 is copied in this one, and the address of A is copied in this one. So that function is directly accessing this array, right? So arrays are only passed by addresses. Next thing, instead of writing brackets, even I can write star here. So this will be an integer pointer, and that pointer will be pointing to an array. See, the difference is this pointer can point on any integer and even it can point on an array. But if you were using brackets like this, then it means it's a pointer to array only. So when you want to be specific with arrays, then better use this one. And writing asterisk is a general method. This is array as parameter. Now one more thing. Inside this function, if I want, I can make changes to an array, and it will make changes to the actual parameter, that is the array of main function. So I'll remove this and show you if I make changes how they will reflect in this array. Here array as a parameter, if I say a of 0 assign 25, then at this place it will be changed to 25. See, the array belongs to a main function only, and this function is able to modify the contents of this array because it is called by address. So you can modify the array also, and you can modify all the elements. Even I can write a for loop and change all the elements. So this is sufficient to show you that even a function can modify the actual parameter. Now one more thing I will show you, returning array as a parameter. So I will remove this and change the function, then I will discuss about it. So here I have an example showing how a function can return an array. So let us look at this code. Here I have main function, I have a pointer inside main function, and I am calling a function by passing value 5. Then the rest of the things, whatever may be there inside the main function. Now this is a function which is taking parameter n, and this is passed by value, right? There is no ampersand, there is no asterisk, so this is passed by value, called by value. And it is having a pointer and it is allocating an array of size this much of type integer, and it is returning p, that is pointer, returning a pointer. So what is the return type? Int square brackets. So square bracket resembles an array, so it means it is returning an array. Yes, it is returning, function is returning an array. And if we see the working, let us look at the working now. Let us start from main function. Main function is having a pointer. This is having a pointer. Then it is calling function fun by passing 5. Function fun is called. It is taking a parameter n. So it's also having n. It will have the value 5. Then malloc, it will allocate the memory in heap. So inside heap an array of size 5 will be created. Then the address of that will be present in P because that is stored in P, and that P belongs to function fun. That array in heap is indirectly accessible by this pointer P. Now, after allocating, it returns a P. So it is returning that pointer. So where it is being taken inside main function in A. So what it is having? It's having an address of that one. So it means A will get the address of this one. So A will be pointing to that array. So it is returning by array, returning by array. So this type of logic is useful sometimes, like a function is allocating a memory in heap and manipulating, storing some data, and then it is returning the array to the calling function. So it is returning, and this function is getting that array created by that function, right? Now, once the function ends, its activation record is deleted. So this P is gone, but A is still there, and A is accessing that array. So this is removed. Now A is pointing on that one. So this is written by array. Now one more thing. Instead of writing square bracket, even I can write asterisk here because it is returning a pointer. So pointer can point on one element or array of element. But when you have given a square bracket means it should point on array of elements only. That's especially for array. But you can use any of these, whichever you are comfortable. And if a square bracket is used, the code itself is readable, and from the code we can read that it is related to an array, right? So any one thing you can use. So that's all. This is how a function can return an array. So we have learned how our functions can handle array, taking as parameter and returning as an address of an array. So we may be using this type of code sometime in our course. So that's all in this video. In the coming video, I will show you how to handle structures in functions.
6 and 7. That's it. This is returning of an array. So this type of thing we may be using it in our programs, that is returning the address of the memory allocated inside a function, and the main function or some other function is using that memory using a pointer. So that's it. So we have seen passing of an array and returning an array which was created in heap. So that's all in this video. You practice this by yourself once. After watching this, you try to do it by yourself. If you stuck anywhere, just come back and watch the video once again. Alright, so that's all in this video.
In this video, we will learn about structure as a parameter. If you are sending a structure as a parameter to some function, it may be called by value or called by address, right? Call by reference is there in C++, so I will show you call by reference also. So first let us look at call by value method. See, for that already I have an example. This is a structure rectangle having length and breadth as the members. Then I have a main function having a variable of type rectangle and it is initialized with 10 and 5, so a variable is created with values 10 and 5. Now I want a function to calculate the area of a rectangle by multiplying length and breadth. So I want to write a function called area. So this function, the skeleton is already here. Now what I should pass from here? Shall I pass length separate, breadth separate? No need. You can send the structure itself. Yes, that is the benefit of structure. You can send the structure itself and the structure is carrying length and breadth. So both will be passed as parameter. So it will be passed as a single variable, single data member. So write R here. So structure is passed as parameter. Now what should be the parameter type of this one? So the argument type should be struct rectangle R. So it's rectangle R. This is called by value. So instead of R, I will say R1. Just a change of names. You should not feel that they are same. This variable is different, that variable is different. So I have taken parameter as R1. Now that is called by value because here I did not write any asterisk or I did not write ampersand. This is called by value. So in call by value, what happens? This object or this variable is passed by value. So a new variable will be created here, a new variable R1, and it will have its own member, that is length and breadth, right? So the values will be copied here. So it means separate object will be created. Yes, separate object will be created in call by value and everything will be copied in the corresponding members. This is the benefit of structure. This is one more thing, one more useful feature. Now here what I want to do, just calculate area. So I have to multiply length and breadth. So directly I will write down return. I will directly write in the return statement R1 dot length. So R1's length, right, into R1's breadth, R1's breadth. That's all. It will return the result and this printf will print it. This is call by value. Now one thing, inside this one, if I make any changes, if I say R1 dot length plus, if I modify length before returning, so this becomes 11. So will it change this one? No, it will not change that one. It is called by value. So the actual parameter will not modify. This is actual parameter and this is formal parameter. If you're making changes to formal, it will not affect actual, right? This is one thing. Now next I will show you call by reference. Call by reference. So for call by reference, I don't have to do anything much. It will be same thing only, and only the thing I have to do here is I should write ampersand R1. Now this is a reference. So a new object will not be created, but the same thing is called as R1 also. Yes, we have already learned about the references. So the same thing is called as R1, and you know very well that this will not be a separate block of machine code. It will be pasted at the place of function call. We have already learned about this. Only there I have to write ampersand and rest of the things remain same only. Then if I say R1 dot length plus, yes, this will modify. This will become 11. That same thing gets modified. Right? So though for calculating area, I don't need call by reference. For calculating area, I need call by value because it is just supposed to read the values. So you should know very well that which function should use which method for parameter passing, right? So this needs call by value, but also I have explained you about call by reference, how to do that. Now in that reference, I can use dot operator. Yes, dot operator, simple as a normal object or normal variable. Now next I will show you call by address. So for that, I will change the function, right? I will write down another function for call by address. Now for call by address, I have changed an example. I am calling a function name as change length. Suppose I want to change this length, right? I want to make it 15. So I can make changes here also. No, I want it to be done by a function. I don't want to do anything inside main function. Like main function, we should imagine it like a manager, and he's having all his assistants, and he don't want to do anything by himself. He just want to assign the job to all his assistant. He knows how to do the work, what the work should be done. So every work he will assign to assistant. So we should imagine like this. So main function can change, but main function is not doing it. Assistant will do it. So that is change length function. So we want this function to change this length. So when you want some function to modify actual parameter, then it must be call by address or call by reference. So we are learning call by address. Let us write call by address. First of all, from here I should call that function. So yes, I should call that function change length, right? Then what is the parameter I should pass? Rectangle. By address, so I should pass ampersand address. So here what it should take? It should take it as a pointer. So struct rectangle pointer, right? Star P. Then along with this also I should pass the new length. So let us say I want to make the length as 20 instead of 15, let us say 20. Then it should also take new length, so it is integer L. So it is taking by pointer. So when you call this function, how it looks like? This P is a pointer that belongs to this function and is pointing on this one. Now we have already learned pointer to a structure. So now you can see that pointer to a structure is useful in parameter passing also. I want to modify that length. So say P arrow, because for accessing this member indirectly using pointer, we have to use arrow. P arrow length assign L. So this length will be modified to 20. That's it. So this is how we can use call by address for the structure. So this type of thing I have used in my course. So whenever I am writing structure and function, so wherever I have to make changes in a structure, I am using call by address because I am writing C language code, right? So basic code I am writing in C language only, so I have used call by address. So from here I am setting an address, and there I am using a pointer, and by using arrow I am accessing the members. So you should be familiar with this code, and if you are comfortable with this one, then you can smoothly follow the rest of the topics, right? So this is the method for call by address. Now one more thing I have to show you. I'll remove this and I'll explain you. Yeah, one more thing that I have to show you. I have written a structure here having a array as a data member and one more integer data member. Two data members I have taken. Mainly array is important there. So we focus on array. Then here inside the main function I have created a variable of that type structure test, and the name is T, and I have also initialized it. So it will have two members, array and n. So array, the size of an array is 5 and one more integer variable is there. So all are initialized. Now, can we send a structure as a parameter in call by value? Yes, call by value can send. But can you send an array as call by value? No. Array can be sent only by call by address. Already we have discussed this in previous videos. Then, but this structure is having an array. Can you pass this by value? Yes, structure you can pass by value even if it is having a array inside. So that's it, the important thing we are learning now. So here I have a function called fun, and I am taking it as call by value. So from here I am passing T. So whether it works? Yes, it works. So what happens when this T is passed? So again a new T1 is created with an array, right? And also n, and everything from here will be copied here. 2, 4, 6, 8, 10, and also value 5. Everything will be copied. So when a structure is passed by value, even if it is having an array will be created separately in the member and it will be filled. So imagine all these values has to be copied. Automatically it is done by the compiler. So this is time consuming. That is the reason compiler doesn't support arrays by value. They allow only call by reference. But if it is inside the structure, they support it. They have to do it. So this will be copied. Right? We are not copying it. Internally it's happening, means compiler will do this one. So yes. Now if I make any changes, how I can access this one? I can say t.a because it's own member, right? It's called by value. And I can say t.a of 0 assign 10. So this will become 10. right? So I can change the value. T1 of 1 assign 9. So this will become 9. This value becomes 9. But this will not change because this is called by value. So I can use dot operator and access the members. So that's all. We have seen how we can pass structure as parameter. We have seen call by value, we have seen call by reference, we have seen call by address. Then also we have seen that even an array is there inside a structure, it can be passed by value. Structure can be passed by value. That's all in this video. In this video, I will talk about structures and functions. See, this is the very important topic. The style of code that I have written here, the same style is followed in rest of the codes. So you should be familiar with this structure or with this style of programming. So now for example, for explanation already I have taken an example. So let us study the example. See, I have a structure for rectangle which we have already seen having length and breadth. And this is the main function. Main function is having a variable of type rectangle. This belongs to main function, that is R. Then the most important thing to observe here is main function is not having any instructions of its own, but it's only calling functions. Yes, everything is done by calling functions. There is a function for initialize, there is a function for area and change length. Let us see the function. Initialize function, this we want to initialize this rectangle by filling 10 and 5. And this is for calculating area of a rectangle. This is for changing the length of a rectangle to 20. Now if you observe these function, this initialize function should modify this one. So function must be called by address. So I am sending ampersand address of a rectangle. Then change length function should change this rectangle, that is actual parameter, this one. So here I am sending by address. Then area, for that we don't have to make any changes, just we want the result, that is length into breadth. So this is called by value. So let us look at these functions. See, this is the first function, initialize, which is taking an address variable R. So this R will be a pointer to this rectangle as we are sending address here. Now using the pointer, it will fill up length and breadth. Then this is area function. This is taking called by value. So it will have its own copy of rectangle containing length and breadth. So this will not directly access that one. This will have its own copy. This is called by value. And next, let us look at this change length function. This is having a pointer and another length, that is new length. So this is also pointing to the same thing. And it is just changing length. These two functions are pointers. They are having call by address, so they are using arrows, and this is call by value, so this is using dot operator, and it is accessing its own rectangle. Now let us see the working of this entire code. Let us start executing. Main function having a rectangle, this one. Then call initialize function by sending an address and new value length and breadth. So length and breadth, this is called by value, 10 is copied in this one, 5 is copied in this one, and this is a pointer to that rectangle that belongs to main function. And r dot length assigned L and breadth assigned B. So this will be 10 and 5. And the function returns, it's not returning anything because it doesn't have to return anything, it is just initializing those values. Then back to the main function, call area function. This is called by value, a new object is created for R, then 10 and 5 are copied, and it is taking call by value, then it is calculating length into breadth area and returning. So it returns integer type, but I am not using that value, just I call area function. Then third, change length. I want to change the length of this rectangle to 20. So send the address, then also a new length, that is 20. Then R's length assigned 20. So this will change to 20. This will become 20. And actual value is a change. Actual parameter is change. So that's all. So I have just demonstrated how we can write down functions upon a structure. Now conclusion. See, this style of programming leads to object orientation. And this is the highest level of programming that you can do in C language by writing structures and functions. How it leads to object orientation and how it is highest, let us see. So this is a structure. This function is related to this structure, and this function area, this is also dependent on the same structure, and this one also. So all these functions are related to that structure only. So in C programming, this is the highest level of programming where we define the structure and we write all the functions related to that structure, because grouping of data at one place is a structure, grouping the instructions for performing a task is a function. So this is the style we follow in C language. Then in coming video, I will discuss the concept of object orientation. So I will show how to write a class So the same example I will take and the similar code I will modify it as a class and show you. So that's it. This code is very important because I am following the same style in the entire course. So that's all in this video. In this video, we learn about classes and constructors in C++. So I am going to discuss the concepts that are useful in the course. So I am using just classes and constructor, not all the features of object orientation. So I will not be discussing everything about OOPS. So here I am going to transform a C language code to C++ code. So we have already seen this in the previous video, this example. So if you have not seen that video, I suggest you to watch that video. This is the best style of coding in C language. I have explained in the previous video. Now I am going to transform this into C++ code, that is using class and also including constructor. So let me show you how to do this. Before that, quickly I will go through this example once again and then I will transform it. See, here I have a structure called a rectangle. This is having length and breadth. And inside the main function, I am creating or declaring a variable of type rectangle. And then inside the main function, if you see, there is no processing involved. There are no operations, just function calls are there. So the function call is for initializing a rectangle and finding the area of a rectangle and changing its length. And in all these functions, I am passing rectangle as a parameter. Right? Initialize function is setting the length and breadth. So it is taking by reference rectangle and taking length and breadth. Area is taking a rectangle. Change length is taking a rectangle by address again, and it is changing length by taking new length. So these are the functions. So if you see those functions, these functions are defined here. And all these functions are related to that rectangle. Now this is the best style of coding in C language. So this I have adopted in my course. Then I have also shown at the places how to transform this into C++. So that style I am discussing now. Let us convert it into C++ code. So watch it very carefully. See, this is a structure. I will call it as a class. Class rectangle. Now, structure is converted to a class. Then this function, initialize, area, change length, all these functions are meant for that structure only. Earlier it was a structure. They are meant for that structure only. If that structure is not there, there is no use of this function. See, it is taking rectangle, it's taking rectangle, it's taking rectangle. So now the question is, why they are outside? Include them inside the class. So my class ends here. So the class starts from here and ends here. So now the class contains data members as well as functions. So these functions have become a part of a class now. See, I'm modifying it. I'm discussing and modifying it. Watch it very carefully. The style is different here. Next, this is a member of a class only. Why does it have to take this rectangle as an argument? Remove this. Then just take length and breadth, two parameters. Then this also, remove this one. It's a part of rectangle only. Just write nothing because it doesn't have to take anything. Rectangle is directly accessible. Length and breadth are directly accessible. Then change length. This also became a part of it. No need of taking this rectangle as a parameter. Only length is required. So just declare length as an argument. So I have made one change. Now few more changes. Again, I'll do it for all the functions. See, this length and breadth are directly accessible. So no need of this variable name. Just length assign L, breadth assign B. Now here, length and breadth are directly accessible. No need of R here because I have removed the parameter. Remove the parameter. Now here also, no need of R. I have removed the parameter. It is directly accessing that length. That's it. So this is initialize function, now area function and change length function. This has become a C++ class. What we do inside our classes, when you have the data members, we declare these data members as private. We declare them as private and we make these functions as public. Because who are accessing these data members? So many functions are there. Why do you need that data to be public? So let us hide it. Everything should be accessible using these functions. So now this has become a class. Now how it will affect inside the main function, I will show that one. Then again I will come back here. Inside the main function, I have created a variable of type rectangle structure. So now I will change it and I will simply say rectangle R. Now we call this as a object. Instead of a variable, we call it as an object. Then how to call these functions? These functions are present inside the rectangle only. So for calling these functions, instead of passing the parameter, I should say r dot initialize, then pass 10 comma 5. Remove this one. Then call this as r dot area. Remove this one. Then call this as r dot change length. Remove this one and just pass 20. Now you can see that earlier initialize function was taking rectangle as parameter. Now initialize function itself is a part of rectangle now. So this is an object and these are the functions, member functions of that object. So once you create a rectangle, what are the things you get? You get length and breadth. These are the two data members, length and breadth. These are the data members. Along with that, we also get the functions like initialize and area and change length. We get these functions also. These are the member functions. So length and breadth are data members and these are the functions. You can call all of them by using dot operator. So this is the transformation from C language to C++. Now one more thing. If you see this initialize function, this is initializing a rectangle. We need this function because the data members has become private. We cannot directly set the length and breadth. Now when do you use initialization mostly? See, usually when we declare or create an object or declare a variable, that time only we prefer initializing. So declaration and initialization. If you remember a normal variable, if you are declaring an integer type variable, then this is declaration as well as initialization. So we prefer the rectangle is also initialized that time only. So instead of passing it 10 comma 5 later on, we want to pass 10 comma 5 here only. We don't want this function. We want direct initialization at the time of declaration only. How it is possible? For that, I should have a function for initialization. But we want it to be called automatically at the time of creation of an object. So yes, same initialize function, I will change the name. I will call it as rectangle. What is this? This is same as class name and no need of void or anything. Just write class name. This is having same name as class name, so this becomes a constructor. Yes, this is a constructor. This will be automatically called whenever we are creating an object. It does the job of initializing an object. Instead of calling that function as initialize, we are calling it as constructor and we are giving the same name as class name. So it's a initializer function. So constructor, we say it's a function which creates the object, and initialize the object, we say like this. So that's what it's having a same name as class name. Now let us look at the class once again. Rectangle class is having private members and the public member function. There's a constructor which is initializing the members, an area function which returns length and breadth by calculating it, and change length. Now these functions are being called here. So let us see the working now. Once we create an object of rectangle by passing 10, 5, then object is created like this and automatically this function is called. This will take 10 and this will take 5. So it will assign 10 and 5. So 10 and 5 are assigned. The next I am calling area function. So this area function will be called upon this rectangle by multiplying length and breadth. It will return the result. So I am not using that value. Then change length. So upon this rectangle only, because this is R, this function is called which will modify length and set it as new length. So I am setting 20, so this will become 20. So this is the style I have adopted for converting C language code to C++ code in my course. Now in the next video you can see I will write on the same class once again, just like a C++ program, right? Write refresh from the beginning.
Structure only, and inside the structure in C++ we can write down functions. So I have written all the functions inside the structure. They are directly accessing length and breadth. They are accessing directly length and breadth. Alright. Then what about main function? In main function, we will create a variable of type structure like this only. Instead of calling initialize and passing r, we will say r dot, because r itself is having initialize function now. So you can access the member of a structure by using dot operator. Now instead of giving r as a parameter to area, alright, instead of giving it as parameter, we will write r dot area. We are calling r's area and remove from parameter, and this is r's perimeter. Now the syntax has changed, right? This is object orientation. So what is an object? Writing the data members and all the member functions together at a single place, we can define a class and we can create its object. So these are object. Object will have its properties and methods, that is member functions. So but I have written a structure here. Yes, you can write structure also in place of class in C++. Let us run this. Length is 10, breadth is 5. It's working. Oh, all the functions inside structure. Yes, this is object orientation. Now, lastly, this should be a class. Now, I will write it as a class. Then I will run it. No, build failed. There is an error. Okay, I cannot initialize like this. Just like a structure, we can directly initialize, but a rectangle we cannot initialize. Okay, I will remove it. I will remove it. Okay. Oh, again the error. What is the error? Initialize is private member, area is private member, perimeter is private. Oh, so because I wrote a class here, all these members are private. If you write struct here, all the members are public. So in C++, structure and class are same. Only the difference is in a structure everything is public, but in class everything is by default private. So if you make it public, then everything will be same as structure. Same as structure. But direct initialization we cannot do like I have done it earlier inside structure. Now run the program. So I have just changed a structure to a class. That's it. Same thing, same result, right? So this program is an object oriented program. I have written a class. Class contains length and breadth, and it is containing all the functions. All right. So we have converted a C language program to a C++ program. So in the entire course, when you are writing a C language code by writing functions and passing parameters as a structure, later on you can convert entire thing into a C++ code by converting into a class like this. Alright, so this will help you because in most of the topics in the lecture we will be writing a function. For that we don't write a class, we write a function only, either in C or C++, right? But writing a class means C++ style programming. Writing just a function means C style programming. That is the reason most of the time I have written functions. So I am saying that I am following C style coding. So that is also a C++ style coding, right? Unless you write a class, you can't say this is object oriented program. So classes cannot be written always unless and until you have a big enough program. All right. So that's all in this lecture. So I suggest you to practice this one. Then in the next lecture, I will write on a complete class.
In the previous video, I have shown you how to convert a C language program to C++ program using a rectangle class. Now the same program or same class, I will write it once again freshly as a new C++ program. So let us write a class for rectangle using C++. So here first of all we should include a header file, that is IOStream, include IOStream. It may be IOStream or IOStream.h depending on the compiler you are using. And if you have to write suppose IOStream only, then you have to say using namespace std, so that you can use scene and cout objects for displaying or reading. I may or may not be using them, but this is the thing that you have to write down in the beginning if you have scene and cout in your program. Now let us write a class for rectangle. Class rectangle. Inside the class, first of all, I need data members. So let us declare them as private. So I need two data members. One is length and the second one is breadth. So this is integer breadth. I'm taking both of them as integer. So if you want to change the data type, you can change them. Then the next thing I will define member function. So I will write all of them inside public block. So the first thing, we should have a constructor. Constructor will not have any return type, but it may take or may not take parameter. So first I am writing non-argument constructor, which doesn't take any argument. So I should initialize length and breadth to some value. So I will assign both length as well as breadth equal to 1. So this we can call it as a default constructor. So I have written them in a single line because I need more space here. Then next I will write down a parameterized constructor. This will be called as constructor overloading. This takes length and also breadth. This I will be defining it outside using scope resolution operator. So this is just a prototype or a signature of a function or the header of a function. So this is a constructor member function. Now next, upon a rectangle, I may need the functions like calculating area or calculating perimeter. Now next function I should have is area function, which should return a result that is integer type. Then one more, integer perimeter, which returns perimeter of a rectangle. Now these two type of functions are there. Now if you want to have other functions like get set functions, you can write them. So I will show only for length and breadth, you can add them. So only for length I will have one function, that is get length, which will return length. So here itself I will expand it and I will say return length. Then the next is set length to change the length. So in the previous video I was calling it as a change length, call it as set length. Now set length void set length function. Now this should change the length to a new given length. So directly I will write in a single line because it has to just change the length. I am changing length assign L. So these are the functions that I need, and I don't have any destructor. I don't have to destroy anything. If you have to destroy anything and if you have any dynamic memory allocation inside the constructor, then you can release that memory inside a destructor. So how destructor is written? It is written just using a class name with a tilde symbol. So it should have a name that is rectangle with a tilde symbol and no arguments at all. So these are the member functions of a rectangle class. These two are constructors. These are overloaded constructor. One is default constructor, other one is parameterized. And these type of functions which actually perform some operations on data members of an object, we call them as facilitators. And then this is accessor, that is get function or getter function, and this is mutator, that is setter function, and this is a destructor. These type of functions are there. I have written all the types of function inside a class. Now this already implemented. These three functions I have to implement them. So I implement them outside the class. So after this I have to write them. So here I will write down those functions. So let us write on the first function, that is constructor, parameterized constructor. So here for implementation, first of all, I should write down the class name, rectangle, and scope resolution, constructor name, rectangle, and it is taking two parameters, integer L and integer B, integer length and breadth. And there is no return type, so directly it starts from here. So only thing I have to do is length assign L and breadth assign B. So if at all you have any validations, you can do them here, checking whether length is valid or not, breadth is valid or not. Now the next function is area function. So I will write down implementation of the body of that function. This is the return type, then the class name rectangle and scope resolution. The function name is area. It doesn't take any argument. So it's also a single line function. So just I will say return length into breadth. Now next function is a perimeter function, so I will implement it outside. Int rectangle is a class name, so I have to use a scope resolution because this function is not an independent function. This is a part of a rectangle class. So function name is perimeter. It doesn't take any argument, and it's also a simple formula and a single line function. So just say return 2 into length plus breadth. So that's the end of a function. Now the last function, that is a destructor. Though I don't have anything to deallocate here, if at all any deallocation required, you can do that inside destructor and you can implement that destructor. Destructor will not have any return type, so directly a class name and scope resolution, and this is a destructor. So inside the destructor I don't have anything to do, so I'll just leave it blank. That's all. These are the functions. I have implemented them using scope resolution outside the class. Now I will write on the main function and use these functions. Let us write a main function here. Int main. Now the first thing, I will create an object of a rectangle, say rectangle R 10 and 5 length and breadth. So this will create a rectangle with length 10 and breadth 5. The next I will call the function. So I need the function that is area and perimeter. I will call them and I will directly display their result. So cout r dot area. This will display area. Cout r dot perimeter. This will display perimeter. If I want to change the length, I can say set length function I can call, and I will change the length to 20. Now if I want to display the length, then I can say cout r dot get length. Length will be displayed. This function will return the length and cout will display it. So this is the end of the main function. Now once the main function ends, this destructor will be automatically called because the object is going outside the scope. Function ends, so a destructor will be called because the object will be destroyed. So this is a fresh C++ class I have written. Right from the beginning I have written everything. So in the previous video I have converted. Now in this video I have freshly written it. Now in my course, at very few places I have written C++ code because most of the time I have written C language code, and when I have finished the topic of data structure, like for example arrays, at the end of the topic of arrays I have written a C++ class for arrays. Then linked list, at the end of the topic I have written a class for linked list, that is C++ class for linked list. So I have collected all the operations of a linked list and I have put them in a single class and have defined it as a class. Each and every function I have discussed them separately, just like C language program, because if you see in this example, if I have to discuss area of a rectangle, then I have to discuss only a function, right? That is the function area of a rectangle. This function I have to discuss. I don't have to discuss the entire class. So like this, insertion in a linked list, so I have discussed it separately and have discussed only a function. Then later I have converted into a class. So at the end of the topics you find C++ code. So there sometimes I have converted a C language code to C++ and sometimes I have freshly written a class like this. So now you are familiar with this one, so you can easily follow the rest of the course. So hope you get a lot of benefit from this course. So one more thing I have to show you, that is templates. How to use templates, what are templates? I'll discuss that in the next video. In this video, I'll explain about template classes. C++ programming support generic functions and generic classes. Generic functions are template functions and classes are template classes. Generic functions, I am not explaining them separately. I am explaining generic classes that include generic function also. So already I have an example class written here. First I will explain that example class. Then I'll show you what does it mean by generic, and I will convert it into a generic class. Let us look at the class. Here is a class called arithmetic and two data members a and b, integer type. Then this is a constructor. Constructor is taking two parameters. Again, the parameter names I have taken same name a and b. So these are the class members and these are the parameters. So we call this as this a or this b, and these are parameters a, b. Then I have just two simple functions for adding those two numbers and returning the result, and subtracting those two numbers and returning a result. So this is a simple arithmetic class, right? So that we can focus on the template. Now next, here I have implemented all these functions outside the class using scope resolution operator. This is the end of the class. Now if you look at this, first is a constructor, arithmetic integer ab. So ab are parameters and this ab are these ab. So to differentiate between them, now the names are same, so we have to say this caps a and this caps b, because this is a pointer to the current object, the same object. So arrow we use, this arrow a and this arrow b, this is a and this is b, and these two are parameters. Now next, this is add function, this is subtract function using class name and scope resolution. So just look at the class one. So you must be familiar with this already. In the previous video I have explained you how to write a class, everything I have explained you. This is adding and returning, this is subtracting a and b and returning. Both these functions are directly accessing the members. Now let us talk about generic classes. For understanding that, first of all, let us look at the class. This arithmetic class is performing arithmetic operation, addition and subtraction on integer type data. What about float type of data? And if I want to use long int, or if I want to use double, then what? So for them, this class will not work. I have to write a separate class for it. Yes. So I should write a separate class for, again, floating point type of data and performing an arithmetic operation. So shall I write two different classes just for a change of data type? Though the operations are same, we will be performing same thing for addition and subtraction. Shall I write another class? No. C++ says that you can use the same class for multiple data types. At a time you can use only one data type. So it works for any type of data. So for any type of data, it is called as a generic class, and that is defined as a template. So now let us convert this class as a generic class using template. So I will just write down the code. It is just like sprinkling some code inside this one, adding something more extra to make it as generic. So how to change the existing class into a generic class, I am explaining that one, and this is what I have followed in my course, right? I have written a class, then I made it as a generic class. Let us convert this into generic. So first of all, this class, the body of the class starts and ends here. So write down template on the top. So say template class T in angular brackets. So say class T. This is template. Now that effect of that template will start from here and ends here. So the class became template. And the variable or generic variable is T, right? Now which part you want to make it as generic? These data members. So call them as T. Means no data type, generic data type. Whatever the data type you want, you can make that data type. So T can become integer, T can become float, or T can become double, anything. Now coming to this arithmetic parameters, what are these? This value will store here, this value will store here. So what is the data type of this? T. So what should be the data type of this? That also T. Okay, change it to T. This also a T. So you have to check it carefully which one will be a template. Don't write everywhere wherever you find int as a T. Whichever should become, you have to find out that and change it. Then add, it will add two numbers, integers or float, depending on these type. So what it will return? The result. If they are integer, result will be integer. If they are float, result will be float. So this should also be t, and similarly this should also be a t. So I have made all changes that are required for making it as a template. Now next, the effect of template ends here. Now this is the body of a function. What about this? This is a constructor belonging to this class. So class is a template, so function also becomes template. So yes, write down template once again here. Why? Because this has finished here. So again write down so that it can start and end here. Start from this line and end here. So write down template class T. Template class T. Class T. So if you observe here, these I have made them as T, so these also will be T. These are template type. Template type. Now, one more thing. This class is a template class. So remember, whenever you use the class name, you should pass a template parameter. So here I am using the class name as a part of scope resolution. So here I should write down T in brackets. Then write scope resolution. This is the change you have to do. Everywhere, wherever you are using that class name, you must pass template as parameter. Otherwise, you pass data type. Then inside the function, there are no more changes, no changes at all. Now coming to this. See, this template has finished here. Then again, I should define a template here. So again, write template class T. Template class T. Then this class name arithmetic is a template, so it must be written like this. Then there are no parameters, leave it. What is the return type? I have changed it to T, so change it to T. Then these two are added, result is stored in C. So what should be the type of C? Same as their type, so C should also be T. Yes, this is also T. See, in my code, almost wherever I have declared data type, variable name, everything is changing to T. But it may not be true always. Remember this one. So you have to observe and change it. Whichever should be changed, only that one you change it. Now, this ends. Again, for this, I should write down a template class. Template class T. Then here, for the class, I should write T here and scope resolution, and this also I should change. So that's all. This class has changed to a template class. Now I will write down the main function. I will use this template class. So just let us write a main function. So here int main function. Now for the main function, I am creating an object of arithmetic. I will create an object name as A. Now arithmetic is a template. So which type of data members you want? Integer, float, double, which one? So here, along with the class name, I should write down the data type, int. So now this object, I will call it as AR, and I will pass the values 10, 5. Now this arithmetic class int, everywhere, wherever I have written T, that will be replaced by int, and this class becomes a pure integer class. So this works for integer type data. These variables become integer, the return types become integer, these parameters integer, everything becomes integer. Now these 10 and 5 are integer values. If I want the result, I can say cout, and I can call that function add. It will give me the integer addition of these two numbers. Now if I want a float class, then again make a object of this and give a parameter as float, and here I will give it as AR1 and pass the parameters like 1.5 and 1.2. These are the float values. Now cout AR1 dot add, this will give me addition of these two float numbers, right? Because the parameter is float type. Here the parameter is integer type. So here the object will be integer and here it will be float. For this one, everything will become float. Wherever I have written T, that will become float. So it means the same class is working as a float also or integer also. So I don't have to write down two different classes. It works for any data type now. So whichever data type you want, you have to mention it as a template. So that's all about the template class. So you can practice this one. So I have covered all the required concept of C and C++ programming that I'm using in my course. So once you have finished this, you can start learning the course. You can start the topics of data structures. And the next section is about installation or setup required for writing C++ programs for data structures. So if you already have the setup and you are already familiar, you can skip that section and you can start with the actual topics of data structures. So that's all. I have covered all the topics that are used in my course. So if you are familiar with this, then you can smoothly understand the course. So hope you will get a lot of benefit from the course. Spend enough time on each topic and practice the programs. That's all in this video.